Thanks. Yeah, I'm Alex DeBrie. I work at Hudl as a data engineer in Omaha, Nebraska.
I'm Kelly Burdine. I work at Hudl. I'm the lead data analyst there. Prior to that, I was in the Air Force for 6 years. I worked in intelligence. After that, I worked at U.S. Strategic Command as an all-source analyst at Offutt Air Force Base in Nebraska. And then for the last year and a half, I've been at Hudl.
Cool. So we're going to talk about promoting a data-driven culture in a world of microservices. And so it's going to be a lot of using data for internal analytics at your company. You know, figure out which products are being used, how your features are being used or not used, user engagement, things like that for internal use. So just a quick overview. We'll give you an introduction to Hudl and what Hudl does. Then we'll talk about Hudl's production data journey and the data problems that came up. And then our solution to it with two teams, data engineering, data analytics, and the key takeaways and a summary. So yeah, we work for Hudl. We're a sports video and analytics company based in Nebraska. We started with high school football teams and basically have all that market. About 96% of the high school football teams in America use us. So now we've expanded out to other high school sports in America and then also grassroots, also more elite level like college and professional and international. So we've got EPL teams, we've got NBA teams, things like that. So just a rundown of how the product works. Imagine you're a high school basketball coach, you have a game, you set up a camera or an iPad to record your whole game. You've also got a manager or a parent, that's tagging the game saying, assists, made shots, missed shots, things like that. And then after the game, you can break down the data, share it with your coaches, share it with your players, skip to all the three-pointers made, things like that. And then, just to give you a number of the scale, an idea of the scale we're working at, had about 4.5 billion video views in the last year, about 5 million users, and 150,000 teams. So we'll talk about our data journey. So this is we got started in 2006, and basically the web app was backed by just a single Microsoft SQL server. So everything's pretty easy there. All the production data is in there. It's easy to run analytics on that. But then in 2010, we're starting to scale a little bit. We have a lot of clips in particular, so we need to split out some of our data models into Mongo. So now our data is split between Mongo and SQL Server. But still pretty easy, right? Like most of it's in these two places, and the important stuff's really in SQL Server, so it's still pretty easy to do analytics. But then in 2014, now we're trying to scale our product team, and we moved to a microservice architecture. So now we've got two different services that are talking to each other that each have their own Mongo database, and we've still got the SQL Server there. Also in 2014, we do an acquisition, so we bring in and they brought in a MySQL server. So now we've got a couple different databases. Then 2015, now we've got a bunch of different microservices. There's Mongo databases all over the place. Still got the SQL servers. And then we've also got just a ton of application logs. So things you want to keep in a production database, like clip views or highlight views or just all kinds of things like that. So now we have data problems, right? And so like every year we have 4 or 5 key metrics we want to track. We call it our mountain goals. And one of our mountain goals for 2015 was to keep track of all football teams that had 3 or more users watching video in 3 different months. We'd call that an engaged team. And it was a key goal for us. Our bonuses were tied to it. And so we wanted to track it really well week over week, see how we're doing. But to pull that data, you need to go to the user's Mongo instance. You need to go to SQL Server and get info about teams and schools. And then you need to search through a bunch of logs to see who's watching video. And this is just a real pain. And to do that, someone needs all these different skills, right? They need to know how to SSH into your production machines, which is scary. And then they need to know SQL. They need to know Mongo query language, and then Excel or Python or whatever they're going to do to sort of tie all that together. So in the middle of 2015, we said, this isn't working. We need to do something. So we spin up 2 new squads, data engineering and data analytics. And that's basically what we'll talk about is what the responsibilities of each of those squads are, how it's worked for us. So data engineering, I'm on the data engineering team. Our product team in 2010, they had a sort of a rallying call for coaches who were their users saying basically, give me my damn video. our rallying call is just give me my damn data. So everyone within Hudl, wants to access the data without having to go to all these different databases. So we have three big questions, right? We've got data in all these different databases. We've got log files, all that stuff. Where do we put that data? How does it get there? And then how do people access it once it is there? So where do we put that data? There's our slide we showed before with all the different databases. Pretty easy here. We just jam it all into Amazon Redshift, which has been huge for us. So a little bit about Amazon Redshift. It's just a SQL-based database that's built for like large analytical queries. It's fully managed on AWS, which is great because all the rest of our infrastructure is on AWS, and it's pretty reasonably priced for like the amount of storage and compute you get. Rob Story, he works at Simple Finance. He did a really good talk at PyData Chicago, I thought, about how to sort of tailor your schema in Redshift, and just some tips they had. Mirrors what our experience as well. So I would recommend going to look at that. Alternatives, if you're on Google Cloud, you can use Google BigQuery. If you're more of a do-it-yourselfer, you can use Hive, Impala, or some of the newer ones like Presto or Druid. If you're an enterprise user, I think there's Vertica and Teradata, which I'm not as familiar with, but you can check those out. So then our bigger question is like, how does our data get there, right? Like in this previous picture I showed, we're going to put it all into Amazon Redshift, but that blue arrow is really like the key work of what data engineering does. In particular, we just do a lot of ETL work, extract, transform, and load. So it's a very simple example. Imagine you have a MySQL database, and you want to maybe all your users are in there, and you want to put them into Amazon Redshift so you can join them with other tables from other databases. You're just going to extract, transform, and load it, right? And like that's a pretty simple path right there. You could probably take 3 hours and write up the script that pulls it out, saves it to disk, does a little transformation on it, and then inserts it into Redshift. Pretty easy. Then the script takes 15 minutes to run. But in reality, you're going to have a lot of ETL steps because you're going to need one for every table in your database. You're going to have a lot of different transformations and loads and all that stuff. And also, like each of those things is going to fail, right? So you just want to build something reliable there, and I would say like definitely use a workflow manager. There are a couple good ones out there. Luigi, which is open source by Spotify, that's what we use and we love it. Airflow is a little newer one by Airbnb. LinkedIn has Azkaban as well. The great thing about Luigi and Airflow is they're in Python. I think there have been a few talks today about both of these, and that past PyData, so you can go and check the videos online. But the three big things they'll give you is like dependency management, right? So you need to, like before you transform and load your data, you need to make sure it's extracted. It'll make sure to do that in order for you. Parallelism, so if you have one instance of your ETL job running, you can spin up another one as well, and it'll be working on different tables. And then idempotence, if it fails in the middle of the job, you don't have to worry about sort of all these weird files all over the place or incomplete loads. You can just rerun the whole job, and it'll know what has been done, what hasn't been done, all that. I'll also just think really hard about your tooling and make sort of repeatable processes. I showed this, it's just like this big blue pipe that goes into Amazon Redshift. But in reality, what you'll have is like 20 different pipes, and you don't want to have to be like reinventing the wheel for each one of those, right? So you need to worry about like scheduling and logging and monitoring and did it work, all that stuff. And like you start off with cron and you just have like this cron script on some server somewhere, and that just turns into a mess quickly. We started using Jenkins, which is like a really good replacement for cron. For just vanilla cron, it's got a great UI, or not a great UI. It has a UI that you can go to, which is nice. And then also just like logging, you can go to the web interface and see all the logs right there. You can have it send Slack notifications if a job finished successfully or did not finish successfully, things like that. And then you have a couple different kinds of triggers. So if you want to just run on a schedule with cron, you can use that. But you can also do dependency based. So as soon as this job finishes, now run this job and this job and this job, or just like git check-in triggers as well. So we have Jenkins, and then I would say we have two big sort of buckets of jobs that we have. We have single machine jobs, and these are ones that can run maybe in 30 minutes to an hour on that Jenkins box directly, and they're not going to tax it and take it down. And so we just run those straight to Luigi on the Jenkins box. And those would be things like, go to Zendesk and get all our tickets from the last day, go to Salesforce, maybe a few different Google Sheets that like the sales teams pass around, and it'll extract those and put it into Redshift, and it's pretty easy. Our second big pattern is like multi-machine jobs, and that's going to be pulling everything out of a database, doing Mongo processing, so turning like a Mongo document into something that fits a relational model more. So doing bigger jobs like that, and for that we just spin up Amazon EMR instances, which allows you to manage like a cluster of machines really well. And then we've just got a pattern down where you make a directory with all your scripts in it. It has a run script in it, and you load it to a particular spot on S3, and it's easy to schedule that job. EMR will pull down that directory, unzip it, and run the run script, and it's pretty easy and reliable that way. So then on EMR, what will happen there is also a Luigi script, either calling Spark or Scoop or something else like that. And then final question for data engineering is, how do people access the data, right? We put it all in Redshift, like what's sort of the access pattern? That's here, right? Like put it in Redshift, we have Hudlies on the far right there, that's our logo, and it's like how do they interact with Redshift? A basic overview of our needs, we want everyone in our company to have access to Redshift. So we've got 430 employees. We want every single one of them to be able to get to it if they need to. And we have a fair bit of data. We've got 24 terabytes in Redshift with 100 billion plus rows. So there's a lot in there, and like a bad query can slow it down. So we need to be careful about that. Commercial options we looked at, Looker and Periscope are two of the real hot ones right now. For us, given those needs before, that was kind of infeasible. One of them charges per row, and then one of them charges per user. So I think both of these would have been pretty expensive for us. And then Tableau also is very popular, but again, charges per row, so it would have been, or per user. So it would have been expensive for us to get 430 people on it. So we use Redash, which is a completely open source tool. Backend's written in Python. It's got a very nice query editor and visualizations. The maintainer, Eric, he's great on it, and he'll accept contributions, he'll give you feedback, all that. I think he just got a Mozilla open source grant, which is awesome. He's also got a hosted version that you can go and pay for, and it's very reasonably priced compared to Looker and Periscope, so that's great. Or you can host your own, that's what we do. We just put it on an EC2 instance and host our own. So yeah, now we have, basically you had that sort of top mess there. Now it's all being fed into Amazon Redshift. You can query it through Redash. Hudlies are a lot happier. Instead of having all these different skills you needed to get access to our data, now it's just down to SQL, right? And then that's sort of where our data analytics team comes in, helping our internal Hudlies get through the SQL aspect. So I'll turn it over to Kelly.
All right, good afternoon. So the mission of the data analytics team at Hudl is to help our employees leverage data to make better decisions. So, a good chunk of our work is us digging into the data, analyzing it, building models, making recommendations, and measuring the outcomes. But another big part of our job is helping all of our employees pull data and analyze it themselves. We have a kind of unique structure at Hudl. Our organization is very flat. If you're familiar with like the Spotify product organization, it's very similar to that. So we all work in very small, very autonomous teams called squads. And so, for example, a squad on the product team, they are pushing code very fast, which is one of the reasons we have this type of organization. And so they need to be able to make decisions on a daily basis. And so if we want to be data-driven, everybody has to buy in to data, okay? So everybody needs access to data, and everybody needs to know how to pull it and analyze it. So this kind of leads us to our data philosophy, which is we give access to our entire data warehouse to every single one of our employees. So we have all of our data under one roof, as Alex explained, and now everyone has access. So problem solved, right? Now we can be data-driven. Well, not quite. So turns out finding data still isn't so easy at Hudl at this point. You still need SQL to be able to pull the data, which it can be a high bar for some people, especially when you're talking about, someone maybe in marketing or a business background that, has really no coding experience. On top of that, we just have a ton of data for a company of our size. So, we have over 10 billion rows spread across 540 tables coming from, 20 to 40 different sources. So a column in one table that is the equivalent to a column in another table, but it's not named the same. So it gets really complex, and that's really difficult for somebody who's not sitting there working in data every single day. On top of that, we have a pretty small data team. We have 2 data engineers and 3 data analysts. So trying to take requests for data for 430 plus people would be pretty daunting and probably next to impossible. So what can we do? Well, we need to remove these roadblocks so everybody can have true access to data. And so we've done a number of things so far that we found to be very successful. And so the first one of these things is education. So we have something at Hudl called Hudl University. It's just an internal training program where employees offer certifications in various topics and teach other employees on those topics. So I'm sure a lot of you that work for larger corporations probably have something similar. And so I basically developed 2 courses, a beginning SQL course and an intermediate SQL course, and taught it in the context of our own data. So not only are they learning SQL, but this allows them to learn where data is stored and how to answer very common questions at Hudl, and just kind of the basic data model that we have, as well as how to use our interface to Redshift, which is Redash, and some basic data visualization techniques. And so once I started offering these, they were very popular. We had probably 100 to 150 people go through the courses, and the number of people querying on a daily basis just went through the roof. So it was very successful. If you don't have kind of an internal training program like this at your company, something like a lunch and learn, a lecture are also good things. There's a lot of great online resources out there as well. And I've been reading recently of a lot of companies actually requiring kind of some basic SQL knowledge for, kind of the business side of operations. So just kind of something to think about. Another problem we had is, with it being so much data, how do you find which table has the data you need? So, for example, if one of our employees wanted to find information about the schools that certain teams belong to, they could go to the query editor and look up the schools table. And so, okay, we see the table, we see a bunch of columns listed there and a basic overall data type, but that's about it. But since Redash is open source, that allows us to kind of edit it and make it fit our needs. And so we went ahead and developed and built out what we call a data dictionary. And so people can click on the table, and now you get a table description as well as descriptions of each of the columns, which has been very helpful. You can also search by that, and that'll pop up. We also added kind of a relationship chart. So this shows you every column that is in that schools table that has a relationship with any other table in our data warehouse, as well as the relationship type and the column that it needs to be joined on. So no fancy diagram yet, but it's still kind of a work in progress. But this really helped a lot. And so now when people have questions, we can kind of steer them here. So another very valuable resource. So the next thing that we did was something that we called derived tables. And so this is basically a way to take messy data, which I'm sure you're all very familiar with, and kind of just make it look not so messy on the other end. So I'll give you an example. So let's go back to that question that Alex mentioned about one of the big goals. So find how many football teams had 3 or more users watch video in 3 different months this year. Okay, so we only need to know SQL, right? We don't need to know all the skills that he mentioned before, but we still have to look across 4 tables, do 3 joins, 1 union, an aggregation, and you have to know at least 4 different combinations of key value pairs that signify various types of watching video. I don't know if you heard all that, but not very easy to remember, especially if you're not working in this every day. So that was really tough for people. It was confusing. there was also some performance issues when you're looking back over a year, 2 years of this. So we created kind of a simplified version where we pull out the unique user ID and team ID for every single day of a person that did various activities. So you see here we just have the user ID, team ID, the date that they did it, and then Boolean actions for watching video, tagging video, uploading video. This is kind of just like a simple version. We have quite a few actions listed in this table, but it's really simplified things for people. Some of you might be wondering why we didn't just do like a view. There's kind of some performance issues there, and so storage for us is pretty cheap. It's that, computing cost is, what gets you. So that's why we made a separate table as opposed to a view. Okay, so something else we did is report automation. With things like Tableau, that's pretty easy, but again, that's really expensive, and so we're looking for a better option. And this is one of the reasons Redash, again, an open source tool, was so attractive to us, because it allowed us to easily automate and schedule queries and reports, without the cost. So, for example, every query can go in and be edited by any user to schedule at various time intervals. So, if they need to know their numbers multiple times a day, just once a week, once a month, it's done. So now you don't have to go in every single day and hit run on these queries. Something you can also do is create dashboards. And so you can have all these queries updating on the time interval that you specified, but then you can kind of aggregate them all into one dashboard. And so you have one common theme for a dashboard. You can see all your data visualizations. It's right there. So it really simplifies things and brings the metrics straight to these users. So we can build out dashboards for these teams. They don't need to know the SQL. And we can just deliver the metrics to them, and then they can even download the raw data behind the outcomes themselves. So it's super helpful. Something else that we've done, we use Slack at Hudl for all our interoffice communications, and so often teams are spread across multiple offices, so that's often their main form of communication. And so we kind of we're relying on people to go to these dashboards, every day and check their metrics, but what if we just bring the metrics right to them? So imagine like a product team, and you have a product manager who's really trying to rally his team around one metric for a quarter, let's say. And so this is something they want to improve every single day on, and they want to be looking at. And so we wrote a script in Python that works with the scheduler in Redash and delivers the metric or the visualization right into Slack and drops in the channel. And so here's kind of an example of what that might look like. And so, every morning you maybe have a morning stand-up or something, bam, there's your metric right there, now you can talk about it. So just to kind of show you some of the success that we've had, just in last month, we had 194 unique users execute a query out of 430 employees. We had about 14,000 ad hoc queries executed, and we have a little over 940 unique scheduled queries that run every single week, and some of those run multiple times in a week as well. So, our team at Hudl has really bought into using data and being more data-driven. Obviously, we still have a lot of work to go. This is not the end of our journey, but we've been very, proud of our success so far. There are some cons to this. Obviously, giving data access to everybody can cause some issues. People pull bad data that they think is good data, make bad decisions. And also, sometimes people write poor performing queries that slow down the whole system. So, and we've created some checks kind of for those things. So kind of the key takeaways here. Being data-driven is really a team sport. You can't just have one leader at the top trying to be data-driven. Everybody needs to buy into it. Everybody needs access. Also important is getting the data architecture in place. So I think this is a really good example of, using open source tools to get your data architecture in place, but you might have hiccups along the way. We used Hive at one point, didn't work out so well. And so getting it right is really important. Otherwise, the longer you go on, you just create more and more technical debt. Making data and metrics accessible, and this doesn't have to mean you give every single employee access to your raw data, but at least the metrics that they need is really, really important. And then being flexible. This structure works really well for us, but this architecture might not work well for your company. But there's a lot of ways that you can kind of piece together open source tools, without having to pay a lot for commercial tools to make it work. And so being flexible and understanding the needs of your company is really, really important. Okay, so just kind of summary of what we talked about today, as well as, again, a review of some of the tools and which ones are in Python. And with that, I'll open it up for any questions you guys might have. Yes? Yeah, that's a great question. And the question was, what's our adoption rate for more advanced SQL? I think on our product side, especially for developers who are familiar with code, a lot of times they're very willing to kind of try that out themselves. But as data analytics, we do take requests. So a lot of times people will just go ahead and kind of request it for us, or sometimes they'll give it a try, it doesn't work out, send us what they have so far, and we'll kind of take it from there. I'd say on the business side, probably less adoption, but once we've seen some of these people go through, and if they kind of graduate the certification program, we've seen really good results. So I would say it's kind of a mix. Any other questions? Yes?
How are you doing the materialized view or prefix table updates that trigger through scheduler? How frequently are you doing that?
Yeah, so we have a few different things, but usually they'll be part of just like a cron job or part of the actual Luigi job that even loads some of the data into Redshift, might refresh some of those tables as well.
So are you able to do that on a minutes or hours schedule, or just more like take overnight jobs?
So most of our stuff happens, like all our production databases are just on overnight jobs. Logs we load in every 6 hours, and then we have batches of, during season now, I would say like probably 70 or 80 million logs we'll load in every 6 hours.
So it's a big materialized table, you're doing those things like.
Yeah, that one will be nightly. Yep. No, not at all. Yeah, and that's like definitely a problem too. And like the same thing Kelly mentioned too, of like sort of like bad queries can sort of infect. Like Redash has like a copy query button, so someone will write a bad query and then someone else will copy it, and then just like it's really hard to stomp it out. But like we work on that too, and yeah, there's no sort of way to get rid of that. But most of our queries, I would say, run under 30 seconds or so, so it's not a huge deal. Yes, so the question is, how is the data dictionary created? And so for like the table metadata stuff, like the table name and the type, that's just taken directly from the Redshift schema. And then, so then each table will have a web page you can go to and just like an editable description block. So that's sort of like user filled in data, all the description stuff. And then same with relations between tables. Someone needs to like go and fill that in. But like our data analysts do a great job of doing that. And then just like other people that have knowledge and experience about particular tables, they'll go in and sort of add that data for other people.
Can you talk a little bit about how you interface Redshift with Mac? Is there an API offered by Mac for you to use?
Is there any what?
How we
API or
interface.
something offered by Slack that you use to port the data to the specific channel within Slack?
Do you know which one's?
Yeah, so I can talk a little bit about that. So we did use the API to Slack, and I think you just need like the team ID, and then you actually type in like the channel. We used a Python package. I think it's called Slacker, and so we used that, and then we just connected to the Redash API, and so we kind of pull it all into the Python script, and then push it back out into Slack.
So it doesn't interface with Redshift directly. Like Redash will, like these are usually scheduled queries that have charts already generated. So it'll say like, go get the latest run of that scheduled query and then just paste it into Slack.
Is there, does your company have like a ticket tracking Jira sort of system, and does this interface with any of that?
So I guess the question was, do we have a Jira ticket tracking system and does it interface? No, we don't pull that in. We have had a request for it and we haven't gotten to it. But yeah.
Can you just talk a little bit about Redash and how hard that was to set up and make on?
Yeah, so the question is, how hard is Redash to get up and going? And it's really easy. Eric is the maintainer and he's great on it. He has like Amazon AMI images, he has Google Cloud Platform images, he's got Docker, Heroku, everything. So you can do that like in very simple instructions to get that set up. Like we didn't have any trouble getting that set up at all. And then he's also got the hosted version, which is very, very reasonable compared to sort of the other paid options out there.
And I'll add one thing to that. Redash was also very easy to integrate with Okta, which is a security extension. For those of you not familiar, and so that allowed everyone in our company, we can keep access to within our company, and it's really easy for them to make a secure connection without having password and stuff. Any other questions? All right, well, thank you for listening to our talk. We appreciate it.